Okay, we're back. This is part 2 of lesson 26, picking up where we left off using the same PowerPoint. You've now seen the basics of how to factor a trinomial of a certain form that starts with x squared or z squared or some variable squared. We're now going to see some slightly more complicated examples, but we're still using the same basic ideas that we've already seen so far in this lesson. So, as you can see, these next couple of problems deal with fractions and decimals. I took these straight from the homework. And I just want you to know that there's a sort of a pattern that I noticed with the fraction and decimal questions. I'm not saying this will happen all the time, but for some reason in MyLabs Plus, the fraction and decimal factoring problems tend to be perfect squares. So I guess I just want you to be on the lookout for perfect squares. What do I mean by that? Well, when you write your answer, there's a good likelihood that your answer will itself be a perfect square, meaning it'll be the same factor twice. Okay, so let's start number 3, x squared minus 1.6x plus 0.64. Okay, so x times x is x squared. I need factors of 0.64. Okay, I'm not going to make a chart for this. For all the factors of a decimal, that's getting a little bit more complicated, but I want you to sort of see this as 64. What multiplies to 64? And then I want you to see this as 16. It's not 16, but just pretend. What multiplies to 64, but adds up to negative 16? Wouldn't that be negative 8 and negative 8? Okay, negative 8 times negative 8 is 64. Negative 8 plus negative 8 is negative 16. Okay, it's not negative 8. It's going to be some kind of decimal. So I'm going to use my calculator to help me out here. If you do negative 0.8 and negative 0.8, that should work. Check it on your calculator. Okay, so 0.8 times 0.8 is 0.64. Negative times negative, positive. And when you add these together, negative 0.8 plus negative 0.8, you do get negative 1.6. Okay, don't worry. There's not a lot of fraction and decimal questions in this section. So I'm just showing you a couple of them, letting you know that it just so happens that a lot of them do involve perfect squares. So look for one number times itself, okay, as you're kind of working through your list of possibilities. So this is my answer right here. Or I could write it as x minus 0.8 squared. Okay, let's take a look at the fraction example. Z squared minus 2/9 z plus 1 over 81. Okay, z times z is z squared. We'll start there. All right, and I guess I kind of should have mentioned this in the previous example, the signs, right? So I was looking in the last example, 2 numbers that multiplied to something that was positive, but they had to add up to something that was negative. Okay, so the only way that a product will be positive is if the signs are the same, right? So in our next example, the same thing is happening, right? So our product is positive, but our sum is negative. How's that gonna work? Well, if my product is positive, it's either a positive times a positive equaling a positive, or in this case, it has to be a negative times a negative. Negative times negative. Okay, negative times negative. Well, I need to come up with factors of 1 over 81. Here's what I want you to do. Break it apart into 2 problems. The numerator needs to multiply to 1. So these 2 fractions that I'm about to fill in, the numerators need to multiply to 1. Well, it has to be 1 times 1. That's pretty much the only option here in terms of factors of 1. The denominators need to multiply to 81. Now we do have some choices here, but keep in mind perfect squares, okay? So try that combination first. Something squared is equal to 81. That's going to be 9 times 9. So I'm going to try that first. Now, if that doesn't work, I have to try something else, but this is going to work. Okay, so negative 1/9 times negative 1/9 is positive 1 over 81. If I multiply across negative times negative positive, 1 times 1, 9 times 9, it works out. And then if I FOIL, if I take that sum of my outside and inside terms, negative 1/9 plus negative 1/9 is negative 2/9. So I'm going to write my answer in this other form. And I will show you the check for this one as well. Okay, so you could write z minus 1/9 times z minus 1/9, or you can write z minus 1/9 squared. And I will check this one using FOIL. Z times z is z squared minus 1/9 z minus another 1/9 z, and then negative times negative is positive. 1 times 1 is 1, 9 times 9 is 81. And finally, I'm going to add these terms together. Z squared, this is now negative 1/9 minus 1/9 is now negative 2/9 z. I already have the common denominator of 9, and then of course there's the plus 1 over 81. All right, so try not to be intimidated by the fraction and decimal questions. Keep in mind perfect squares as sort of a guide for what to try first, so you don't feel totally stuck. All right, good. Now we're going to see some other variations coming up. Again, we already know the basics of how to factor these trinomials, but now we'll see how can the problems become maybe a little bit more complicated. So first thing to notice here is there may be more than one variable. Rather than just x squared, there might also be a y squared or a g squared or something else. So let's take a look at how that will affect our answer. We still get to start with x times x. X times x is x squared. Our last two terms here need to multiply to negative 18y squared. So here's what you can do. If you see that second variable showing up at the end of your trinomial, just stick a little extra variable in your parentheses. Now we get to focus on the numbers. Okay, so here's what just happened. I did x times x is x squared. There was going to be a number in front of these y terms here, so it might be 3y times 7y or something like that. There's going to be a y in each one. Y times y, that's where that y squared will come from. So now that we know the y's are there, we can kind of temporarily ignore them for a second, and we'll do our product of negative 18 and our sum of 7. Okay, so 1 and 18, 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, here's 6. Okay, so here are my combinations that will work. For my sum to be positive 7, again, we saw this earlier, I need my bigger number to be positive when I'm taking my products here, because in order for my products to be negative, the signs need to be opposite from each other, one of each, one positive, one negative. I'm going to leave the bigger numbers positive and make the smaller numbers negative. Now when I add them, negative 1 plus 18 is 17, negative 2 plus 9 is 7, negative 3 plus 6 is positive 3. So here's the winning combination, negative 2 and positive 9. So here's what I do. I go right back and I fill in those two numbers right next to the y. So excuse me, so my answer will be x minus 2y and then x plus 9y. And that will be my final answer. X minus 2y, x plus 9y. Now, if I check my answer using FOIL, like we've done many times, we will see where this xy comes from. That can be a confusing part of these problems, looking at the xy term in the middle and saying, wait, where am I supposed to get xy together? Here's where it comes from. When I check, again, using FOIL, x times x, there's x squared. Your outside terms, x times 9y, there's your first xy term. You can write 9xy or 9yx, but I'm going to keep it xy. Here's my inside terms, minus 2yx or minus 2xy. And then finally, your last two terms, minus 18y squared. Positive 9 minus 2 is positive 7xy. All right, there we go. So let's try number 2, very similar. T squared plus 17tg plus 70g squared. Okay, so t times t is t squared. I am going to have that g at the end, or I can fill it in at the end of the problem if I'd rather not put that second variable yet. So maybe we can just kind of temporarily ignore it and just focus on our numbers. I need my last two terms to have a product of 70 and a sum of 17. Okay, now I've been making these complete lists here. If you just want to write the first one you think of, if that works, great. You don't need a complete list every single time. Sometimes it'll just come to you, it'll feel like magic, and that's great. So if you're just thinking of it right away, fantastic, that's fine. This is the combination that will work. 7 times 10 is 70, and 7 plus 10 is 17. So there's your product of 70, and then there's your sum of 17. Great. If you wanted to fill in the complete list just to be extra sure, of course, that's fine. 1 times 70, 2 times 35, 3 doesn't go in, 4. Oop, and now I'm out of order. 5 times 14, and then 6, and then 7. Okay, so a little bit out of order. This would be the complete list. If you add up all those different combinations, the only one that would actually add up to 17 is that 7 times 10. All right, so we'll do t plus 7, and then t plus 10, and oops, now I need to go back and remember that there's this other variable. So at the very end of the problem, maybe that's when you put in that second variable, that g squared. Okay, so my true final answer is t plus 7g times t plus 10g. And there it is. And I could FOIL again, just like last time, t squared plus 10tg plus 7tg. There's your 17tg, and then your last two terms would be 70g squared. Okay, I did not write out the full check for that one, but you certainly could. It would look a lot like the previous problem when you FOIL. All right, good. So now you've seen that these problems can have more than one variable. Usually what that looks like is there's a variable squared at the beginning of the trinomial, and there's a separate variable being squared at the end. So you kind of just fill that in at the end of your answer. All right, good. I'm just looking ahead. Okay, so the next set that we have, number 3 and 4, these problems now should look a little bit different. Here's a reminder that we should be checking for a GCF. Now, we haven't really mentioned that in this lesson so far because we haven't needed to, but as we move on and learn different kinds of factoring, we will need to pay attention to whether there's a GCF, whether there's a greatest common factor. And the sooner you notice it, the easier your problem will be. Okay, so in this first example, 2y squared minus 8y minus 90. The smallest number that I see as a coefficient is 2, so let's see if that's the GCF, and it is. Okay, so each of these terms is a multiple of 2. In other words, 2 is a factor of each of these numbers, so I can factor out a 2. And it couldn't be anything bigger than 2 because 2 is the smallest coefficient anyway. All right, so I'm factoring out a 2. Each of these terms gets divided by 2. So here's what I'm left with. 2y squared divided by 2, that's just y squared. 8y divided by 2, that's 4y, keeping the minus sign. And then negative 90 divided by 2, that's negative 45. All right, that 2 that we just took up, that will be part of our final answer. So it's good to bring that down. We've seen that before with factoring by grouping problems. When you take out a GCF, it's a good idea to just make a note of it right away before you forget. And then you can go back and worry about actually factoring that trinomial. Okay, so I'm now going to focus on what's left here in parentheses, y squared minus 4y minus 45. So I need factors of negative 45 that have a sum of negative 4. Okay, so here's my list of factors of 45, 1 and 45. 2 doesn't go in, 3 and 15. 4, nope, not a factor, and then 5 times 9. 6 doesn't go in, 7, 8, and then back to 9. Okay, now this time, because I need my sum to be negative, as I'm looking at signs here, I need the bigger number to be negative this time, so that when they add together, they're adding up to something negative. Okay, so negative, negative, negative. And now when I find the sum of each of these, 1 plus negative 45 is negative 44. Definitely not, not the one we want. 3 plus negative 15 is negative 12. 5 plus negative 9 is negative 4. That's the one right here. Okay, so I'm going to need a positive 5 and a minus 9 in my answer. So let's do that. So let's see. Positive 5 and then minus 9. And of course, I already maybe should have had the y's there as well. Okay, so here's my final answer. I have the GCF of 2 already brought down. Y times y is y squared. 5 times negative 9 is negative 45. And when I distribute, when I check this part right here and I FOIL, here's what I get. Y squared minus 9y plus 5y, and then minus 45. I would add those together and then get minus 4y. All right, and that's what we started with. And if I wanted to check even more than that, then I would take, basically when you're checking, you can kind of go in reverse order. So then I could check by distributing the 2 and make sure we got back up to where we started. But really the important part to check is this factoring the trinomial part of things. Okay, so here's my final answer, 2 times y plus 5 times y minus 9. Once again, I could write my answer in a different order. I could write the y minus 9 first and then the y plus 5 if I wanted. All right, next problem, number 4. 50c plus 5c squared minus c to the third. Let's first rearrange this in descending order. So the highest exponent is actually this 3 here. That c to the third. And notice that there's a minus sign in front of it. So when I rearrange this, I do need to bring that minus sign out to the front. Okay, so whatever sign is to the left of your term, that's the sign that you need to kind of stay with it. In other words, it would not be correct to just write c to the third. I need that minus sign there. Next, I'm going to have that plus 5c squared. And then finally, my last term will be plus 50c. Now, maybe you're noticing, wait, isn't the last term supposed to be a constant? Yes, actually. So that brings us to the GCF. There is a GCF here, a greatest common factor. Each of these terms has a factor of c. So we could say that our GCF is c. But because it starts with a negative, whenever your expression starts with a negative coefficient, plan on factoring out a negative. So not only are we factoring out a c, we're going to factor out negative c. All right. We've done this before, factoring out negatives. That's just going to mean we're about to change the signs of the terms as we fill in our parentheses. So negative c to the third divided by negative c, we will be left with positive c squared, right? Because we're essentially subtracting a 1 exponent from each of these terms because we're factoring out c. So we'll be left with sort of fewer powers of c left over. Our next term, 5c squared divided by negative c, that's now going to be negative 5c. Again, 5 divided by negative 1, that's now negative 5. C squared divided by c is now just c. Okay, next, plus 50c divided by negative c. So again, change the sign. 50 divided by negative 1 is going to be negative 50. C divided by c, this essentially cancels out. Now I have that constant term at the end. So take a look at what's in blue here, c squared minus 5c minus 50. That sort of matches what we've been working on so far in this lesson. That sort of looks like a regular trinomial that we're used to. Now, I've just drawn an arrow to bring down my GCF like I did in the previous problem. That minus C will be part of my final answer on the outside. So minus C, and then I have these two parentheses. Okay, so now we get to work on factoring the trinomial that's left over. C squared minus 5C minus 50. So I need factors of negative 50 to have a sum of negative 5. So I'll run through a quick list of factors of 50. 1 times 50, 2 times 25, 3 doesn't go in, 4 doesn't go in, 5 times 10, 6, 7, 8, 9 don't work. Okay, so this is my list. I just need to fill in some negative signs. Just like the previous problem, I do want my bigger number to be negative so that I can have that negative sum. So my choices are really 1 times negative 50. That adds up to negative 49. That's not going to work. 2 times negative 25. That adds up to negative 23. That's not going to work. It's going to be 5 times negative 10. Okay, because my sum is then negative 5. So when I fill it in, here's my final answer in my parentheses. So by the way, I already have the negative C on the outside, but when I'm filling in my parentheses here, they each start with C, because C times C is C squared. And then for my numbers, I just decided that 5 and negative 10 was the correct combination that would multiply to negative 50 and add up to negative 5. So I'm going to write negative C, parentheses, C plus 5, and then parentheses C minus 10. And that is my final answer. Okay, so these two examples that we just saw, they each had a GCF. We saw one with a GCF, greatest common factor of 2. And then in our most recent problem, we saw a greatest common factor of C, but actually it was negative C. The reason we factored out a negative is because that leading term, that leading coefficient was negative. All right, good. We're almost done. Let's see. Yeah, we just have 2 more to go. These last 2 have a higher degree. So up to this point, for the most part, every problem has involved something squared. These last 2 problems have a higher exponent. Now, you might be ready to take out a GCF of some kind, but you can't. So that's, you know, in our previous problem, when it was C to the 3rd, we were able to take out a C. That's not possible for these problems. So we're just going to deal with the higher degree that we have and take it from there. So let's take a look. Number 5 says s to the 4th plus 4s squared minus 21. Okay, so there's no greatest common factor. So let's just set up our parentheses and see if we can figure this out. Instead of s times s, which might be what you'd normally be thinking of here, s times s doesn't work because that's not s to the 4th. Instead, take this exponent of 4, you're essentially cutting it in half. So you're splitting it apart equally. So instead of s times s equaling s squared, here's what we're going to do. 4 divided by 2 is 2. So we can just put a 2 exponent on each one of those s variables. So you have s squared times s squared. That's actually s to the 4th. Okay. Finishing up this problem is similar to the other ones, okay? So I still need to now come up with these last 2 numbers, and these last 2 numbers do need to have a product of negative 21. So factors of negative 21, my sum is going to be 4, so 1 and 21 or 3 and 7. Those are my options. It's going to be something with a 3 and 7. I just need to figure out which one's negative so that my sum is 4. Let's see, we'll make the positive number be bigger and then the negative number be smaller. Okay, so I need negative 3 and positive 7 because those 2 numbers multiply to negative 21 and negative 3 and 7 do add up to 4. Okay, so I'm going to fill in my answer. S squared minus 3 and then parentheses s squared plus 7. This is my final answer. Now we will check it. Okay, when I FOIL, when I distribute s squared times s squared, that's s to the fourth because I'm adding the exponents. My outside terms, there's my plus 7s squared. My inside terms would be minus 3s squared. And then finally, negative 3 times 7 is that minus 21. When I combine those middle terms, positive 7 minus 3, that's positive 4. And then the s squared is still there. So s to the fourth plus 4s squared minus 21. Okay, good. One more to go. Hang in there. All right. So similar problem, trinomial. This one has a higher degree and it's 6. There's no GCF here. So it's w to the 6th plus 16w to the 3rd plus 60. Last time we had s to the 4th. We divided that exponent in half. We can do the same thing here. The exponent is 6, so when we divide that in half, we get 3. So I'm going to fill in w to the 3rd as sort of the first term in my parentheses here. So w to the 3rd times w to the 3rd is w to the 6th. Everything is positive in this problem, so I can just immediately put some plus signs. That's nice. My last two terms need to multiply to 60 and add up to 16. So I'll make my list. There's a lot of factors of 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, and 9 are not factors of 60. So nice long list here. If I add these up, again, I'm finding a sum. 1 plus 60 is 61, 2 plus 30 is 32. And you might have been noticing that as we're making these long lists, the closer your numbers are to each other, the smaller their sum will be. So take a look, 1 and 60, that adds up to 61. Whereas all the way down the list, 6 and 10, that only adds up to 16. And take a look at these numbers in the list of our sums here. They get smaller as you go down. So just a little pattern to notice. The last pair in our list is the one that will work because we wanted our sum to be 16. So 6 and 10 are the numbers that will work here. So our final answer is w to the 3rd plus 6 times w to the 3rd plus 10. And when we FOIL, we would get w to the 6th, and then 10w to the 3rd plus 6w to the 3rd is 16w to the 3rd for your middle terms. And then finally, 6 times 10 would be 60. Okay, good. So we've made it to the end of lesson 26, part 2. The lessons are getting a little fuller now, if you can't tell already. So there's going to be a lot of part 1s and part 2 videos coming up, trying to break it down into manageable chunks. All right, good. So at this point now, the types of factoring that we've seen are GCF, grouping, and trinomials. Our next lesson will deal with more factoring trinomials, but we will get to see what happens when there's a leading coefficient other than 1, because it's going to change the process a little bit. All right, well, I will end here. This might be the class is starting to get harder at this point, so please make sure you're keeping track of where you got stuck, what questions you have, and bring those to our conversations when we meet together. Okay, thank you very much. I will end here, and I'll see everybody soon.